Welcome to the viewers. Today we discuss the topics of final value theorem. First of all, we state the theorem at first. If GT maintains Dirichlet conditions in any finite interval of t, and is of order e to the power at t tends to infinity, where a is another constant, and then limit s tends to 0 is gs is equal to limit as t tends to infinity gt, that will be g infinity. Now we are going to prove this part. Let gs be the Laplace transform of g dash t, then by definitions of gs, that will be 0 to infinity e to the power minus st gs is equal to 0 to infinity e to the power minus st g dash t dt, and it's clear s is a complex parameter of Laplace transform. Now, due to the conditions we imposed on gt and g dash t, so imposing the conditions of gt and g dash t, we can say gs is continuous function of p, functions of s. That means we are saying since gt and g dash t are piecewise continuous, that means maintaining Dirichlet condition in any finite interval of t. So we can say by definition gs, that will also the continuous functions, and it's a continuous function of the parameter s. Therefore, for the conditions of continuity, we use that's the left hand side and right hand side, and the functional value at p equals at p tends to 0, that means p equals to 0, that means left hand limit and right hand limit and functional value. So this is limit s tends to 0, gs is equal to z0, that will be equals to 0 to infinity g dash t dt. Here we put g0, that will be 0, so it will be 1, and g dash t, which imply limit s tends to 0 gs. If we put here, it will be gt, so it will be g infinity minus g0. Again Gp equals to Laplace transform of, and it's clear, Laplace transform of Gs equals to Laplace transform of G dash t. So by the property of Laplace transform of differentiation, we can say S Gs minus, there is a property G0, we prove early videos, and now proceeding as P tends to 0. As limit s tends to 0, we have limit s tends to 0 Gs, that will be limit s tends to 0 s Gs minus G0. And using the conditions in the earlier, therefore limit we know already from the definitions, as in the earlier cases we obtained here, and that's the definitions here. It will be taken at equation number 1 for limit s tends to 0 Gs. We find here in equation 1, that will be G infinity and G0, and also from the here using the Laplace transform of derivative of any functions and finding here another value of Gs, and taking here limit G tends to s tends to 0 in this way, limit s tends to 0 Gs, that is limit s tends to 0 Sgs minus G0. Taking it equation number 2, from 1 and 2 we obtain limit s tends to 0 Sgs minus G0 is equal to G infinity minus G0. So we can say from these two sides, which imply limit s tends to 0 Sgs, that will be G infinity. So we prove this theorem. Finally, it's an asymptotic property, and we prove the final value theorem. So today we end our classes. Thank you.